So, this lecture will continue with the story of mathematics in modern India. So, I will start with the continuation of how our Indian scholars started rediscovering our tradition of mathematics and astronomy. I will recount the names of some of the most important people. Then modern international scholarship on Indian mathematics and astronomy also I will summarize. After that we will briefly discuss development of higher education and research in India in the first half of 20th century. Then more importantly we will summarize some of the highlights in the development of modern mathematics in India in the last 100 years. Mostly I will be able to give only the names of persons rather than details of the work. So, at least in Ramanujan's case I could summarize half a dozen results by him, even that will not be possible. First of all, I am not technically adequately competent to do that sort of a thing also. These are lot of highly technical work done by our mathematicians. Finally, I would like to make an assessment of development of higher education, scientific research and mathematics in modern India in the world context. Where does India stand in the world of science and mathematics? We would like to know where are we going, where do we stand. So, this will be the outline of today's talk. So, this study of Indian works continued with people like Vindeshwari Prasad Dwivedi, Babuaji Mishra, Gopinath Kaviraj, Kapadia. More interestingly, the Anandashram series in Pune came up with editions of many works. Many of them we are using in our course like Mahabhaskariya, Laghu Bhaskariya, Laghu Manasa. Similarly, from Kerala also some of the important Kerala school works started getting published. Aryabhatiya Bhashya Nilakantha was published in 3 volumes. The Tantra Sangraha was published around 1950s. Karana Paddhatiya Puttumana Somyaji got published. Malur Rangacharya translated, edited and translated the Ganita Sara Sangraha about 100 years ago. He was a professor in Chennai. P.C. Sengupta was a great scholar who edited and translated Khanda Khadyaka. I have already spoken about the work of A. Krishnaswamy Iyengar on Chakravada. Vibhuti Bhushan Datta is a great name. He first did a DSc in hydrodynamics in 1921, but from his young age he had an inclination for sannyasa. He became interested in history of mathematics under the influence of Professor Ganesh Prasad. So, during the 8 years 1926 to 35, Datta published over 50 papers on various aspects of Indian mathematics, and he collected lot of manuscripts, and this constituted the core of the great magnum opus History of Hindu Mathematics, which was published in 2 volumes. Soon enough Datta left the university and he took up sannyas. He has written a huge number of books on Vedanta in Bengali afterwards. He handed over this manuscript of the history of Hindu mathematics to his junior colleague Avdesh Narayan Singh. Avdesh Narayan Singh started the Indian group on Indian mathematics in Lucknow. He was a professor in Lucknow. He got the 2 volumes published in 1935 and 38, but there was a 3rd volume, the manuscript of which existed, which was supposed to contain geometry, trigonometry, calculus and various other topics such as magic squares, theory of series, permutations and combinations. This did not get published. Even when the book was reprinted from Bombay in 1961, this was not published. Later on, due to the effort of R.C. Gupta and K. Shukla, this appeared as a series of articles in the Indian Journal of History of Science. Ramavarma Maruthampuran from a royal family in Kerala edited the mathematics part of Yukti Bhasha in 1948 with copious Malayalam notes, and in fact this was the basis for all the works on Yukti Bhasha by Professor Rajagopal and others. So, this was the pre-independence period. In the post-independence period, the major effort to study Indian mathematics and astronomy, the main promoter of such a study is what is called the Indian National Commission for History of Science, established under the Indian National Science Academy in 1965. In 1971, they came up with a landmark publication called A Concise History of Science in India, which even today remains the only available book summarizing evolution of science in India, edited by Bose, Sen and Subarayappa. Subarayappa brought out a revised edition now published by the Universities Press. The Academy started the journal Indian Journal of History of Science, which is the leading journal in which technical articles on history of science in India are published, and mathematics and astronomy do take a prime place there. Maybe about 30% of the articles or even 50% would be in mathematics and astronomy. C.T. Rajagopal I have already mentioned his work on infinite series in Kerala mathematics. C.N. Srinivasa Iyengar, his book on history of ancient Indian mathematics in 1967 is a beautiful short book which all students can read and understand. He in fact directed a thesis on Indian astronomy also by Somayaji, which is also a very beautiful work published from Karnataka University. Saraswati Amma was a Sanskrit scholar who went to Professor Raghavan and said, I want to do PhD, and he asked her, oh, you have a BSc degree, why don't you work on something different than Kavya or Alankara or Vyakarana, why don't you do some work on mathematics? And that work became a very nice work, and ultimately it resulted in this really first comprehensive study of geometry in ancient and medieval India in 1979. Saraswati Amma also guided R.C. Gupta in his thesis on trigonometry. S.N. Sen was in the Indian Association of Cultivation of Science. He came under the influence of Needham when he was in UNESCO, and he was associated with the Indian National Science Commission, and he has edited and published several books. Kripa Shankar Shukla is one of the most important scholars of Indian astronomy and mathematics in the second half of last century. He has edited and translated several works, especially the works of Bhaskara, Mahabhaskariya, Laghu Bhaskariya, Aryabhatiya Bhashya, but also Vateshwara Siddhanta, Laghu Manasa, and is one of the, and he also published the third volume of Datta and Singh in the form of a collection of articles. Other great name in history of astronomy and mathematics, or in the study of Indian mathematics and astronomy in the second half of last century, is of Professor K.V. Sharma from Chennai. He was with the New Catalogus Catalogorum, and at that time itself he got interested in the works of Kerala school and published Gola Deepika, Venva, Roha and Siddhanta Darpana. He worked with Professor Kuppanna Shastri on Vakyakarana. Then he shifted to Hoshiarpur. There he really published over 50 works which have really brought to light the entire corpus of the Kerala school of mathematics and astronomy, Drik Ganita, Golasara, Kriya Kramakari, Tantra Sangraha with Yukti Deepika, Jyotirmimamsa of Nilakantha, and his last was the magnum opus Ganita Yukti Bhasha and its English translation, which got published in 2008. R.C. Gupta was a student of Saraswati Amma in Ranchi, and he started the journal Ganita Bharati in 1979, which is really one of the important professional journals devoted to history of mathematics in India. Gupta himself has authored more than 500 papers on various aspects of history of mathematics in India and the world. He was awarded the K.O. May Prize in 2009. A.K. Bagh has been running the Indian Journal of History of Science as its editor for the past 30-40 years. George Joseph, many of you would have seen his book The Crest of the Peacock, Non-European Roots of Mathematics, whose third edition has come. It's been translated into several languages. He has been at the forefront of the debate against Eurocentrism in the history of mathematics. Recently, of course, several scholars in Tata Institute like Professor Balagangadharan, Sridharan, Dani, etc., Professor Divakaran have also done interesting work. I mean, they are professional mathematicians and physicists, have done interesting work on Indian tradition of mathematics. And here are some of the books which have appeared on the subject in the last 7-8 years from various Indian scholars. Now about the modern international scholarship, George Kay was name came up in the context of Bhaksali manuscript. I think that he was one of those persons who was dismissive of the Indian tradition and traced most of it to Greek and other sources. He wrote a couple of works in early part of 20th century. Neugebauer was a major scholar of history of astronomy and mathematics. He was a mathematician trained in Göttingen, but then he shifted to United States and founded the famous history of mathematics department in the Brown University. He has published huge amount of material on Babylon, Greek and other civilizations, the history of exact sciences. He has produced the Pancha Siddhantika and the astronomical tables of Al-Khwarizmi, which are based upon Indian astronomy. Nagibai wrote a paper on Tamil astronomy in 1952 where he suggested that the Vakya methods which were given in Warren's Kala Sankalita are indicative of an entirely different older Indian tradition which he called Tamil tradition. Another great historian and mathematician van der Waals joined the bandwagon, and he also wrote a paper on Tamil astronomy in 1956, and they were sort of approvingly cited by our Professor S. Chandrasekhar in his famous Nehru Memorial Lecture on Astronomy in Science and Human Culture delivered in Delhi in 1968. Of course, now it is well established that the Vakya method goes back to Vararuchi, and major improvements in it were made by the Kerala school. And so today Pingree writes that the Vakya methods, misnamed Tamil, they have generated some interest among the non-Indian astronomers in the 1950s and 60s. David Pingree is one of the most well known names in the history of astronomy, specializing in Indian Jyotish Shastra, astrology also, and he focused mainly on the issues of transmission between different cultures. He was a student of Ingalls in Harvard, later worked in Chicago, then came to the history of mathematics department in Brown. He has published more than 20 books and several articles, edited and translated Pancha Siddhantika, Vriddha Yavana Jataka, written a history of Jyotish Shastra, but his main work is the Census of Exact Sciences, of which 5 volumes have appeared. They list alphabetically all the works in Indian mathematics and astronomy, along with the detailed references to the manuscripts that are available in different manuscript catalogues as published by the various universities. They also give information on the publications of these works. French scholars have also been working systematically. The older set Renoux and Filiosa wrote important papers on Sanskrit grammar, philosophy and sciences. Then Billard wrote on the history of Indian astronomy, and recently an interesting thesis by Agatha Keller translating the Ganita Pada of Aryabhatiya Bhashya of Bhaskara with detailed notes has appeared. Interestingly, there is a school of Japanese scholars working on Indian mathematics and astronomy. Kiyoshi Abuti was one of the older school who worked on the relation between Indian and Chinese astronomy. Yano, Hayashi and Kusuba, whose names you have heard already, they have written a book in Japanese on Indian mathematics. They have translated the Ganita Sara Kaumudi of Takkarperu together with S.R. Sharma. The authors in that are called Sakhya, Sharma, Kusuba, Hayashi and Yano. Hayashi himself has edited Bhakshali manuscript, Bija Ganita, Kutakara Shiromani, and Kusuba and Ikeyama have worked on Ganita Kaumudi and Brahmasputa Siddhanta. There is one Japanese scholar, Ohashi, who worked with Professor Shukla on astronomical instruments. So it is a big school compared, given the number of people working on this kind of a subject. These are some of the international books which have been published on Indian astronomy and mathematics in recent times. So between 1900 and 1950, the growth in higher education was only modest, 5 to 15 universities, colleges going up from 145 to 270, students going up to 85,000, professional colleges, students going to 20,000. The Indian Institute of Science was set up in 1909 with the munificent donations of the Tatas and the government of Mysore. The Indian Science Congress Association was started in 1914 with the first session in Calcutta. The Indian Academy of Sciences was founded by Raman in 1934 with 65 founding fellows. It has about 1060 fellows now. The Indian National Science Academy was parallelly started around 1935. Sir Louis Farmer was its first president. Meghnad Saha became the first Indian president, shifted to Delhi in 1951. While setting up the Indian Academy of Science, Raman tried to give an agenda for the academies or for the Indian scientific community. Essentially, he was trying to highlight the importance of building a national scientific community and associated institutions for fostering scientific research in India. A detailed editorial which you can read, I have put it down here. One of the main things Raman is trying to say is that it is true that the spirit of science and its service are international, but is it not also true that every nation has its own academies, learned societies, magazines and journals? India will have to organize and develop her national scientific institutions before she can enter into the comity. This was a call to the scientific community to work as a national scientific group that will foster science in India. Now, I will quickly trace the important names in the development of mathematics. This will only be names now, their work I cannot really discuss in this short period, but perhaps it is good to know these names. Prior to independence, we have Shamadas Mukhopadhyay and Ganesh Prasad, both in Calcutta. Anand Rao, who was a very important professor in Presidency College. Mahalanobis, who founded the Indian Statistical Institute. Professor Vaidyanatha Swami, who was here in Chennai. Rajchandra Bose, who was in the Indian Statistical Institute. S.S. Pillai, who worked in Annamalai University. T. Vijayaraghavan, whose name you came across in the discussion on magic squares. Meenakshi Sundaram, who is also a very famous mathematician, he worked in Voltaire. But in the last 50 years, in our post-independence era, the most famous Indian mathematician has been Harish Chandra. Harish Chandra was a student of physics from Allahabad, then he went to Bhabha, and then he left to Cambridge to work with the renowned Dirac. He did his thesis on Lorentz group, and then during a stay in Institute for Advanced Study in 47 to 49, Dirac was also visiting, Harish Chandra shifted to mathematics. Then he taught in Columbia, later on came back to Institute for Advanced Study, and he is really a pioneer in the field of what is known as the field of harmonic analysis of Lie groups. His name was considered for the famous Fields Medal that is to be given before the age of 40, and its equivalent it is thought of as the Nobel Prize in mathematics. So, Harish Chandra was born in 1923, I think, 1923. So, in 1958 he was due, but somehow it was thought that already René Thom was getting, and he belonged to the Bourbakist group, and people did not want more than one person from the Bourbaki camp to get, and Harish Chandra did not get the Fields Medal, got of course FRS, and late towards the end of his life he also became a fellow of the US Academy of Sciences. The two premier institutions which have fostered mathematics research in India have been the Indian Statistical Institute and the Tata Institute of Fundamental Research. The Indian Statistical Institute was founded in 1933. It also started the journal Shankha or Sankhya. The Professor C.R. Rao, a famous statistician, he was a student of Fisher in London. He trained most of the famous mathematicians and statisticians in Calcutta. He is well known for his work on Cramer's Rao bound, Rao Blackwell theorem, etc. Since 1978, Rao has been a distinguished professor in many American universities. Professor S.R.S. Varadan, he was a product of the Statistical Institute. He went to the Courant Institute of Mathematics in New York. In 2007, Professor Varadan was the first Indian to be awarded the coveted Abel Prize. Tata Institute started a mathematics school, and Bhabha invited Professor Chandrasekharan, who was then in Princeton Institute of Advanced Study, to come and start the school, and many important mathematicians were trained in this school. 3 of the Tata Institute mathematicians have been awarded the distinction of Fellow of Royal Society. C.S. Seshadri, who founded the Chennai Mathematical Institute here, M.S. Narasimhan and M.S. Raghunathan have all been awardees of the FRS. So, these are some of the major names. I mean, one could go and list many more names, but one should also describe their work. So, in the next 25-30 minutes, I will try to give you an assessment of the growth of science and the growth of mathematics in India, and place it in the global context as to where does India stand in higher education, where does India stand in global scientific research, where does India stand in global mathematics research. As you can see, the development of education in India has been phenomenal. From independence, 27 to 564 universities have come, from 600 colleges to some 33,000 colleges are there. Secondary schools have grown even more, about 2 lakhs. The primary schools have also grown from about 2 lakhs to 7.5 lakhs. So, there has been a big growth of education in India, and the number of students studying there has also gone up significantly. In 1950-51, there were only about 4 lakh students in colleges. Today, there are about 170 lakh students in studying in higher education, 1.7 crore by when I am saying today, this all refers to 2010-11. So, in the last 2 years this number would have gone up further. 13.5 crore students in the 5 primary, 6.2 crores in the middle school, 5.1 crore in the senior secondary, and 1.6 crore, 1.7 crores in the colleges. This is the kind of enrollment that we have. But this enrollment has to be understood in relation to the demography of India, that how many of the people in that corresponding age group are attending this institution, because India is today it has a population of 120 crores. So, we have to understand, to see the progress in education, we should look at what is called the gross enrollment ratio, which is the ratio of the number of students in the particular section divided by the corresponding age group, in which the total number of children in the corresponding age group. So, the enrollment in primary is almost more than 100. That means that the age group data, many more students are studying in the primary schools. But the enrollment in upper primary, which enrollment even in primary was very low in 1950, it was 40%. It is only around 2000 that it is crossing 100%. Enrollment in upper primary has gone up from 12 to about 85. But in secondary education itself, you see the enrollment is only 50%, that is from 9 to 12 classes, only 50% of the children of the corresponding age group are going. And there is something called the dropout ratio in India. By the 5th standard, about quarter of children drop out. By 8th standard, about 40% of the children drop out. By 10th standard, almost half the children drop out from the education stream. This is also a very important indicator. But now we quickly come to higher education only. The school and other education systems we will not bother. So, this already I told you, 33,000 colleges and about 564 universities, about 8 lakh teachers, about 1.7 crore students. That has been the growth. So, our universities, which we counted at around 600, 300 of them are state universities, 43 are central universities, 65 are institutions of national importance, 130 deemed universities, 100 private universities. So, these are the degree awarding institutions, and of the 33,000 of this 634 universities and 33,000 colleges, you can see the number of colleges has grown prolifically in the last 2 decades. In 1990-91 there was only 7,000 colleges, there were 12,000 in the beginning of the last decade, and now there are about 33,000 colleges. Teachers have also gone up to about 8 lakhs. So, first is the gross enrollment ratio in higher education. So, you take the age group 18 to 24, what is the total population there, and you take the number of students enrolled in higher education. So, divide the latter by the former as a percentage, that is called the gross enrollment ratio in higher education. It was very low in 1951, it was rising, so it rose to almost 5% by 1980, but afterwards it has been sort of growing rather slowly. It has grown 7 times in the first 30 years. In the next 30 years, this figure is actually contested, so it has hardly grown 3 times. But now to understand it, we should understand it in the global context. So, what is the gross enrollment ratio in various countries in the world? That is with which we have to compare. So, this is the UNESCO's Global Education Digest of 2012. So, they are giving 18% GER for India with 20.75 million, 2 crores. This is more than the 1.7 crores I mentioned. I think they are taking into account students in the distance education scheme also and things like that. So, that is I think what will make it 2 crores, and that gives an enrollment ratio of 18%. The world average is 29%, and East Asia Pacific, Korea is 100%, Japan 60%, Thailand 48%, Malaysia 40%, Indonesia 23%, and of course China, which has a total enrollment more than ours. We have 20, that is 2 crores, they have about 3 crores in their colleges. It had a very low gross enrollment ratio of 3% in 1992, it has risen to 16% in 2002, and it has risen to 26% in 2010. So, the moment they decided to go for higher education in a big way, they have been able to move very fast. USA of course has 76% gross enrollment. So, it has a total enrollment. India is second in the world in this data. Chinese have about 3.1 crores, India has about 2.1, USA has about 2.05. So, that is where we stand in the gross enrollment in the world as a whole. And next is, how do we stand in higher education? So, the breakup for this higher education is something like this. About 18% of all students studying in higher education study science, about 36% study arts, about 17% study commerce and management, about 4% medicine, about 2% law, 3% study education. That is the distribution by subject. And the distribution by the, so 86% of the higher education students are what we call as undergraduates, only 12%, about 20 lakh students are in postgraduate institutions, and less than 1%, about 1.3 lakh students are in research. So, this is the kind of breakup, and therefore, consequently the total number of PhDs in India is of the order of 10,000, of which 3,000 each year. I mean this is in the year of 2009 and 10. Science PhDs is about 3,742, arts is 3,500, engineering and technology is about 1,000, medicine is 337. So, this is the personnel, this is the growth in quantity. So, what is the output? So, output is usually measured, one in terms of scientific publications and another in terms of patents, etc. I am only looking at, since we are looking at mathematics, pure science, we will look at the output in terms of scientific publications. So, between 96 to 2010, where does India stand? Currently, India is producing about 3% of the world scientific publications. USA is about 21 and China is about 13.5% of the world scientific publications. If you take the next page, South Korea is producing about 2.5%. Our mouse is moving. But the growth from 96 to 2008, India has more or less, it was about 1.83, has gone to 2.96. The Chinese were about 2.74 in 1996. Currently, they are contributing about 13.5% of the world scientific output, and this is in numbers. This is about 8,43,000 papers in those 3 years, which means about 2.8 lakh papers per year. Indians are producing 1,85,000, which means about 60,000 scientific publications are each year are emanating from India. There are other countries like Taiwan, South Korea, Brazil, which have shown considerable growth in this period. Brazil has grown more than 2 times, Taiwan has grown about 2 times, South Korea has grown more than 2 times in the last 12 years. In 1970, the people who studied growth of science in India, they almost hailed India as a research superpower in the third world. There is something called the Science Citation Index, which is a major database of all scientific articles and also analyzes citations. So, Eugene Garfield, who is the sort of originator of this Science Citation Index, wrote, he made an analysis of the publication data of 1973 and the citation data. Citation means the number of times the paper is referred to by others during the 5-year period, and he called India a research superpower. So, in 1973 about 3.5 lakh articles were indexed, about 84% of the articles came from the first world and about 90% of all the citations also came from the first world. But then he is saying, amongst the top 25 countries in terms of the number of articles written by their authors, only 2 third world countries appear, India and Argentina. This is in 1973. India is considered to rank 3rd in the world in the number of researchers. This is a old thing. So, in 1970s this would have been the situation after US and USSR, but it ranks 8th in the number of publications. But then he is saying that the Indian researchers have authored half of the 16,000 articles written from the third world, and the only other country is Argentina, which is the distant second, accounting for 1/5 of India's output. Clearly India is a research superpower in the third world. This was the sort of impression that the situation in 1970s was conveying on the growth of science in India. So this is the 1973 data. US has about 1.6 lakh papers which are cited about 1 million times, that means 6 citations per paper. Amongst all these 25 countries, India, which had about 8,000 papers, has a citation index below 2, which is of course the lowest amongst all these 25, but in terms of the volume of publications at least, India ranked 8th in the world, and it was the only third world country to be significantly performing in science then in 1970s. But this situation seems to have gotten totally transformed and reversed in the next 30-40 years. So this is a DST study. This was a study made by Thomson Reuters for the DST 2 years ago of scientific publications in various countries of the world. So you can see the publications of India from 1981, they have gone up from about 15,000 to 40-45,000. The share of Indian publications in the world science publications has come down from 1981. It was about 3% in 1981, it has come down to nearly 2% in 1996, and has again gone up to around 2 to 3% to 3.5% by 2008. And what has happened in the same period is that many other countries have moved considerably faster and forward. So here we have for the same period, this is India, this blue curve, almost between 2 and 4. This yellow of course is the tiger, China. It had less than almost 0.2% in 1981 of the global publication share. It has gone more than 10 to 12% by 2010. Russians are fluctuating, they were about 6%, they are there, but all these other countries are coming up, Korea, Taiwan, Singapore, Iran. You can see all of them are rising and coming almost near to India, if not more than the share. They are all tiny countries in comparison demographically, but in terms of their scientific output, they seem to be of the producing of the same order of magnitude as India in the share of publications in the world. This is what has happened in the last 20-25 years, and the Indian situation is more or less stable around between 2 and 3% of the world scientific output. It is not merely quantity, you can analyze things in terms of quality also. The number of papers which are cited more than 100 times in the last 20 years, there were only 800 Indian papers, whereas 2000 Chinese, 1000 Korean, 700 Brazilian, 2000 Israeli papers were cited. So it is not merely a matter of quantity that others are moving fast, they are moving in terms of quality as the usual way in which it is understood. Again, in terms of the total number of research personnel in the world, Indian share is about 2%, whereas the USA and European Union have about 20% of all researchers in the world. The Chinese are moving very fast, and they also now have about 20% of the researchers in the world. So all of them have about this in thousands. So this will be about 1.5 million, China, USA and European Union. India has about 1.5 lakh researchers, about a tenth of that. But this is also significant. This is called the per capita amount spent in PPP terms. PPP terms means not the exchange term of 1:55 rupees per dollar, but in what is called the purchasing power parity. We find that the Chinese are spending almost half of per scientist as the Indian. So it is not really that we are not spending enough on our scientists or some such thing. We may not be spending enough still, but the others who are spending much less are able to perform much more. So in the number of PhDs awarded also, India had about 8,000 in 2008, China had about 30,000, South Korea, which had a very low number, 280 in 1983, has about 4,000, Taiwan 2,000, Japan 8,000. So like that, this is the way. So we are not really producing adequate number of PhDs for getting that kind of scientific output that others are moving towards. So now that was about the position in science as a whole, and by now you can guess that that will be reflected in mathematics also it will not be, the situation in mathematics will not be too much different. So this is the sort of Thomson Reuters web of knowledge database, the ranking by papers, ranking by citations for the publications in mathematics in the last 10 years, 2001 to 2011. So USA is producing about 7,500 papers per year, Chinese about 3,500, Indians are producing about 580 papers. So in terms of number of papers, we are about 14th, below South Korea, below Poland, below Spain, and Taiwan, Brazil, Israel are almost on our heels, even Turkey, Iran. And by citation also India is I think somewhat lower, their 6,000 papers are cited less than 2, we are in the same sort of, and in the, I think the total world publications this will also come around 2.4 or 2.3% of the share of world publications. So this is the growth of mathematics in India compared to China, Israel, Brazil. This is some other study. It is important because even 10 years ago this fact was highlighted that we are really lagging behind in our research, our output is not adequate in terms of the fact that we are somehow stagnating, whereas many other countries are really moving, who were hardly considered as major forces in science in 1970s or even early 1980s, they are moving to a situation where they are becoming major scientific powers in the world. And so here you can see between 1985 to 99, this is the graph of Chinese publications, and this is the graph of the Indian publications, and others are catching up even then. This is the more recent Reuters study. I think they have put India in saffron color for whatever purpose. So this is the Chinese, they caught up with India around 1989 and they have moved up in 1985. This is the Russians. So after 1996 the Chinese have gone out of this graph because this is 246%, they have gone to a different order of magnitude, the Russians are still there, but all these others, Korea, Taiwan, etc., are all coming close to India. Brazil, they have a share which is quite. So this is the kind of picture that emerges. I do not need to repeat it again and again. If you study these quantitative figures more carefully, you will see various nuances of this picture. So let us quickly try and summarize the situation as I understand from these figures of the state of higher education and research in India, including mathematics. So one is we have this low enrollment in high schools and secondary schools, which is the input to our higher education, it is around 50%, and at the same time we have this 50% dropout by class 10. Second is that the numbers enrolled in higher education is not growing really fast. We have an GER, gross enrollment ratio, which is around 15%, even that figure needs to be very well confirmed by the trends in the next few years. That means only 1/6 or even 1/7 of the boys and girls in the age group 18 to 24 are getting into university, whereas the world average is about 1/3, 29% or 28%. There are only 550 universities which grant degrees, there are more than 33,000 colleges and an enrollment of about 17 million. So that will leave on the average only about 400, 500, 600 students on the average per college. So this is the general picture. On research and postgraduate education, only 12% of the higher education students are going for post graduation, and less than 1% of the students are in PhD, and in science the situation is that we are producing only about 3,700 students per year in PhD. And in terms of the output, so India, which was hailed as a research superpower in the third world in 1970s, has exhibited a rather halting growth in the global share of science publications in science. It has stayed around 2 to 3% in 1980 to 2010, while many countries of Asia and Latin America have shown much higher rates of growth, and they have either attained the status of India or have crossed them, and their demographically they are sort of very, very small compared to India. In mathematics also this the same thing. In fact, between 1981 to 95 it declined Indian share in world publications in mathematics. it has stayed around 2% during 1996 to 2010. Again, many other countries have. So, this data is all standard, much of it is taken from National Science Bureau Science and Engineering Indicators for 2012, UGC's Higher Education at a Glance 2012, UNESCO's Global Education Digest 2000, this for the world comparison. For our own thing, there is this DST's bibliometric study of India's science publications, evidence for changing trends 2012. There are the studies of B.M. Gupta, Madan Arunachalam and others. These 3 articles discuss the important figures in the development of modern mathematics in India in the first half of 20th century. People like Shyamdas Mukherjee, people like this Vijay Raghavan and all this S.S. Pillai and all their work is discussed in great detail. So, with this sort of I come to a close of the study of modern mathematics in India. Modern mathematics did take root and blazed a great trail with the native genius Ramanujan in the beginning of last century, and after independence we have fostered the growth of modern science and mathematics in a fairly big way, but somehow in the last 30-40 years we do not seem to have gone up with it in the way we ought to have really gone about developing our higher education and research. So, our sort of situation seems somewhat stagnant. Essentially, it appears that a very small percentage of Indians are participating in this activity of higher education and research compared to the really potentially large population of youngsters that we have in our country, and that seems to be at the crux of the problem, and that gets manifested in various other ways, and therefore that results that only there are few institutions in India which you would be naming as doing research, and they will not have really the kind of numbers that will be there in corresponding kinds of institutions all over the world. Say there are several reputed universities in USA which have about 30 to 40,000 students studying in the same campus, and I do not think there is any university in India where in a single campus you are training undergraduates of that kind of a number. So, like that there are various factors, language, the proliferation of this affiliated colleges which are not linked with the research and higher study. So, many factors which is an inheritance from the British created higher education system in India, which we thought was very valuable and took it over without making any major fundamental alterations in it. So, we made few alterations, but we made no fundamental alterations from it, and sort of the limits of stagnation of that system are very visible in the last 2-3 decades, and unless we do that transformation now, either in this decade or in the next decade, we will not be really contributing to the world's knowledge, nor will we be establishing a new sort of genre or mathematics, a new school of mathematics that is worthy to be in continuation with the great tradition of mathematics that we have discussed and described during the course. Thank you very much.